This is a string representation of an object, but as you can see, it is not very useful. You basically have the module name, the class name, and a memory address or an ID number of this object. Instead, we would like it to be something more useful. So here we have a class called dog, and this dog class essentially has properties such as the name and the age of the dog. What we want to do is, rather than print out this garbage looking string, we want something a bit more useful, something that's a bit more user friendly. So what you can do is there's a built-in function that you can use. This function is called __str___. So this is the exact built-in function that you need to type in. That is, the name cannot be any different than what I've shown you on the screen here. And then what you can do is it takes in one parameter, which is automatically passed in, so you don't have to supply it, and then it returns the string. So this is an F string. So using string interpolation, we are going to type the string dog, then name is equal to name of the dog, and the age is equal to age of the dog. So basically, it's referring to these two variables over here, refer to the variables over here, and rest of it, like here, that's just string, and that's string 2. So now if I run this code, and you can see the output is we get a dog, name is equal to max, age is 2. Whereas previously, if you don't have this function, so if I just add a number 2 at the end, so this becomes the invalid function. And run this again, you can see, otherwise you get this string over here, which is not very user friendly. So what you can do is just use this function, and then you, rather than getting this, what you will actually get is something much nicer like this. Why should you represent your objects that you create as text? Why would you want to display them in this hard format to read, which doesn't really make any sense or describe the object that you have created? So here we have created a dog object from the dog class, and it is represented by a dog named Max, age of 2. So in our class, you can see we have a dog class, and it takes in parameters of name and age when it's initiated. Wouldn't it be nice that we actually get to read what this dog class is about when we print it, rather than printing this memory address, which to an end user probably doesn't make any sense? And what I mean by that is the user of the class. So another coder who's using your class. So basically this representation here is a string representation that stands in for an object when the object itself can't be shown. So rather than printing the memory address and so on, it's much better to print what actually describes the object, such as this. So as you can see here, this is just a memory address. So objects live in memory. So it would be nicer if we actually displayed what the object actually represents. But another valid point is terminals can only display text. So this text representation that comes in by default by Python is not very user friendly. So you want to make it more user friendly by implementing this function over here, which you supply an F string into and refer to the variables of the class instance that you are using. So in this case, name of the dog and the age of the dog. So that's why when you run this, you get this output, name of the dog and the age. And this is terminal friendly. You can use it in logs, in debuggers to find out about an object much more easily. So here, for example, when you're trying to debug the item or the issue, you can just do a print of D, and it actually shows you, okay, the dog is actually name is Max and the age of 2. So if there's something wrong with the age, you're quickly able to determine it by checking the logs or the print statement in your terminal. So again, main point is it is user facing string representation. So this is much easier to read than what we had before as a default, which is the memory address. So we said that this function basically needs to describe the object. Now, there are two ways to describe the object. One, which is this way, and the second one, which is this way. You could just simply return a simple string, this is a dog. So if we set that, so if you just print this is a dog, this isn't very user friendly. So technically this is valid, but it is useless. So here, this string is useless to the user. Doesn't really describe the object like this one with the name and the age. This is because it uses data. There is no data representing the name of the dog or the age. Somebody printing this object can't really debug because it doesn't really tell them what the dog is about. This says this is a dog. And of course, with this information in the debugger, the coder cannot recreate this object because they don't have any information on it. But if they had information such as the dog's name and the age, they are able to recreate the object and debug properly. Whereas previously, if you just say this is a dog, they can't really debug. So that's why it's important to have an accurate representation of the object like this, and the function str function coded up like this and not like this. So this is a bad one, and this is a good way of doing it. Let's take a look at object representation with string or repr representation function in Python. So both of these functions pretty much do the same thing, except they don't. Sorry, that was a trick question, but let's have a look at why they are different. So here, as you can see, the syntax is pretty much the same. So we're just getting the f string, we're getting the dog name, and we're getting the name and the age. One thing that you may notice is I have used exclamation mark R here, and I have not used it over here for the name. Let's see what the impact of this exclamation mark R is versus not having it. So here is the output. With the exclamation mark, you can see when I create the dog object, I have added in a new line character. So when we do the str version, you can see that the line break over here that you don't necessarily see. But when you do exclamation mark R, you actually see the line break character as you originally intended it in your original input. So you do see that with the exclamation mark R. So this bit over here, that's what makes the line break appear in the output like this versus like this without it. And the other important difference I want you to realize is that there's a print statement over here while there is no print statement here. So when you use the str function, this is intended for user-friendly print statements, while D is used by developers for debugging. So although both have very similar syntax, but they behave differently. Now, if you are thinking, if I comment this out, so can this change its name so that it's invalid, so you cannot find it. And now when you do, and you can see the output here, for the print statement, it still prints the user-friendly version. But for this statement over here, just for the D or debugging, it just prints this. So in summary, str is for human and user-friendly readable string. So for print, this works. Str is your choice that you should go for. repr is developer-friendly. So when you have used repr, you can use it for things like just typing in the object variable and a outputs. So if I re-enable this function, repr, and now if I run this over here, you can see just by doing a D, we get this output versus a print statement for str. So this is user friendly for developers. And as you can see, it is used for debugging too. So here, this is an average action of a developer trying to debug the code, saying what does this variable actually represent. In this case, it represents the dog that's been created, so you get this output. So repr is also compatible with repl, which stands for read what you type, evaluate, print the result, and loop back for the next input. So this is basically what you see in Jupyter notebooks. You can just print the last variable in the cell and it will output the correct result. So just remember, repr is developer friendly, str is user friendly, human readable. So this is a perfect example. This is human readable and this is developer friendly. A human would have to use a print statement. A developer or machine can just use the variable name and it would be represented like this automatically. So they both look very similar, str and repr. Just notice that you can do things like this, and with repr you can do things like this. That's why you need repr for this to work. Let's take a look at the fallback order for str and the representation function. So what do I mean by fallback order? So what I mean is when you do a print statement like this, if I run this and do a print statement, you can see that you get user-friendly representation of this D object. This is because over here we have declared the str function. This is a special type function that's built into Python, but you have to define it in your code, in your class. So here I have a dog class, and what I want to do is I want, whenever a user does print the variable D, where they've defined a dog or created a dog, I want to know what's in this D variable in a user-friendly way. So we get output like this. So what happens is if you don't define any of these functions, so if I comment out these functions, if I comment out str, and I comment out the repr, and if I run this again, and then if I click on to here, and you can see when you don't have any of those functions, you get this output. So the fallback order comes in this fashion. First, it looks for the str function. If that exists, it will execute it. Next, it will look for repr. If that exists, it will execute it. And finally, if both of these do not exist, then it will execute a standard one, which is over here. So you might be wondering, how does this standard one actually get generated? So this gets generated by, if you do D, so that's your variable, and then underscore dot. And then if you look for something called class, and then another property called module, and that gives you the module name. So up to this point, it gives you main. Because we are in the Jupyter notebook, that's what the module is called. And then by the same fashion, you can do D, and then you can do the name of the class. So notice the underscores. So if I were to print this, you can see that we get the name dog. And then to get the ID, you just use the ID function and give it the reference to your object, and that will give you the unique ID that represents this object. And you can see every time it gets changed, you run the cell, it changes to a different ID number. So as you can see here, it keeps changing. So essentially everything put together to get this string, you get something like along the lines of class module name, which is this main part over here. And then you've got the class name, which is dog, and then the object reference ID. So now moving back to the fallback order, so you can see this is the default one. So now what we'll do is we'll just take this line out and we'll just use D. So you can see at the minute, the print statement and the D, they both practically print the same thing. But as soon as we add the string one, so as soon as we add this, so now that we've added that str function, you can see that for the print statement, this is working. But for doing your repr or just printing the variable, we still get this. So then what you do is, if I take that out and just use the repr one, because this one takes priority over everything else. So you can see here, str is now commented out and repr has been left. So now if I run this again, you can see that we get for the print statement, and if we're just printing the variable without the print statement, we get the same output. This is because repr takes priority. So if it can't find anything, then it will use the default object. Otherwise, it would use repr. And then finally, if it can find string, then it will use the string one. So now if we add the string one, so here I have enabled them. If I run this again and then go down here and run this again, and you can see now for print statement, it's using the str version and it's using the representation function for where we just do the D object. Let's look at the conversion flags as part of string interpolation or F strings. So here you can see there is an exclamation mark S. So what does this actually do? Especially when we're using the _repr function. So if we scroll down and have a look, so the repr function basically is to give a user-friendly name to your class object. So here, this is a class called dog. We expect the name of the dog and the age. So if you have the _repr function, then essentially when you do a print of this, you get an output that is user-friendly like this, that it prints the dog's name and age. If you didn't have the repr function, as you know, so if I comment this out and if I run this again and run this again, you can see if you don't have the _repr function, you just get this output when you debug the variable D or just print it out. So let's reactivate our function over here by uncommenting it and run this again. And if we run this again, and as you can see here, you've got the dog name printed and the object printed in a friendly way rather than a memory representation. So going back to the conversion flags over here, so you can see this bit over here, exclamation mark S. What this does is when you print out the name of the dog over here, so we are in the _repr function. If we go down over here, you can see when the dog name is printed out, it's without any quotation marks. But if we use the conversion flag R in here, which actually calls the repr function itself for converting the name. So the string that is of name called the function that's built into the string interpolation. So if we run this over here and run this again, and you can see the difference is now it's got quotation marks. So the developer, you know that this is definitely a string. So let's look at a practical example. So here you have a string. You can see Max is the dog, and you can see the dog emoji here. So if I were to run this over here, we get three different outputs. If you use the S conversion flag, so the S conversion flag gives you this without any quotation marks, but the R one gives you quotation marks like this surrounding Max and the emoji like this. And then the third one, there are only three supported ones, is the ASCII character. So here you can see since these are valid ASCII characters, you get Max printed again. But since the emoji is not a valid ASCII character, you get the underlying Unicode reference number. So now you know the difference between S is without quotation marks, R is that I actually show you it's a string, and A is for ASCII characters. So Max is ASCII compatible, so you see the same Max, but since the emoji is not, you actually see its row code, Unicode reference number. So going back to here, that's why we see quotation marks around Max, because we used exclamation mark R. So your question might be, why does the ASCII flag exist for string conversions or string interpolation or the F strings? So the reason this exists is, as you can see from this example, if you were to get a string like this in a file or from a user that has Max and cafe dog, you can see here when you just print it as a string with a string conversion flag, it looks all great. There is nothing that looks odd with this. But what you see is with the raw data, you still don't see any problems. You still don't see any issues with this. All it has are the quotation marks around the string. But with the ASCII version over here, what you see is you see two ASCII characters, and that's where the issue is. So a system that expects only ASCII characters, you can see the E here is not a valid ASCII character, and here the dog is emoji. So emoji dog is represented by this Unicode character. So why does it exist? Essentially, it allows for ASCII only logs. So where you need to print logs, you can see this would be compatible versus an emoji and this E symbol. Debugging and encoding issues. So if you use a function that expects ASCII characters only, so only the ASCII character and not an emoji or this E symbol, then you can use the ASCII conversion flag to give you equivalent ASCII codes, and these would cause no issues with your system or the function that you're trying to use. So it'll help you get around encoding issues. And of course, then that means legacy system compatibility. So if you have a system that doesn't like emojis, as in the past, some of the systems could not cope with emojis, then you can use the ASCII representations. The final one, of course, is safe output across different environments. So with emojis, compatibility issues could occur. So here you can see that these two would be represented as ASCII characters. The emoji would become this ASCII code, which would mean that it's just any ASCII characters from here, so the system will not crash. But remember, modern Python is Unicode first. So even the terminal stuff over here, you can see it's Unicode compatible, and the terminals don't need to just handle ASCII characters. They are perfectly fine to handle Unicode characters. And just to show you a function where you could end up with a problem. So here I'm using the S variable here, and S variable you can encode into ASCII. So of course we don't have ASCII characters here. We are using emoji Unicode characters, and this E is definitely not an ASCII character. So if I try and run this, you can see this is where the problem will be. So this Python function, it needs to convert it into an ASCII, and it can't because it's saying that the ASCII codec can't encode the character XE9. So here, XE9, as we saw, is this E symbol. And if we take that out, so if we change it to a normal one and run this again, now you can see that it can't encode the emoji. So the emoji over here can't be encoded. So this is where you will end up with issues if you don't use the ASCII representation. So by using this conversion flag, it will let you see problems with your characters that you might otherwise not spot. But remember, most of new Python, modern Python is Unicode first, so there'll be no issues, and most terminals handle Unicode quite well across many systems and environments. This is your introduction to inheritance in Python. So here we have a dog class. This dog class has an initialization method that takes in a name. So very first thing you do is when you want to create a dog, you call this initialization method. And the way you call it is just by using the class name and supplying the parameter or the argument. So here, this parameter is name, and the argument you supply is max. Notice that I use the word argument versus parameter. So this is the term parameter coming in, but when you supply it, it becomes an argument. You're telling it this is your argument for this parameter. So then this will assign it to the class for the object instance. So that particular instance for this dog, which is represented by this variable called D. This dog is able to speak, so it has a speak function. The def keyword is used to define a function, and then you can name the function whatever you want. The initialization method must always be double underscore init. So this needs to be always like this, but this function can be anything else you want. So you can call it speak, beak, or seek, whatever you want to call it. You can call it as you please. So this will return the string woof. Then what you can see is I want to create another dog class, but this dog class needs to inherit all the things that I have already created. So I don't want to repeat myself and write speak and this initialization method again. So instead, what I will do is in the bracket, so you can see how the class is declared. So class here, dog, using the word class and the class name. Here, you've got the word class and class name, but in the brackets, which you don't have over here, you supply a class name of something that already exists. So this one, we created a first dog, so we supply it into there. And then you use the 2 colons. So these colons are exactly as a dog class. But this class has an additional function called work. This work basically says call out the name of the dog from the dog class self.name and say the dog is working. So let's look at this example. So here we're creating a simple dog called Max. Then we're creating the dog called Rex. We're printing the dog's name. So that's Max's name. Max is able to speak. So here you can see we print its name and speak. So that's Max and it does both. And then we have Rex over here. So Rex is able to say its name and speak both. Same as Max could do it. And then you can see over here, Rex is working. This is the additional function. It doesn't exist on the dog Max. So as you can see that for Rex, which is the working dog, it has inherited the speak and the name attributes that exist in the dog class, but it has got an additional capability, which is that it's a working dog. So it has the work function. So the work function is accessible. But if you try to do the work function on Max over here, Max doesn't have a work function because Max is an ordinary dog. It is not a working dog. And that's your basic introduction to inheritance. Basically, you create a class and then that class you can inherit in this fashion. And then this new class basically gets everything that's already been coded out, such as the name and the speak function. So you didn't have to write that again in your new class. Let's have a look at the overriding behavior in Python and what does it actually mean. So here I have a dog class. This dog class, as you can see, has an initialization method. So this is a double underscore init method, and that's a standard method you can define that takes in some parameters. And in this case, we're passing it a standard self parameter, but also the name parameter. So the name parameter will be the name of the dog. So when somebody creates, for example, a dog down here, then they can pass in the name of Max to their dog. And then this attribute over here will get that name to say that dog's name is Max. The function in here, this is a standard Python function. It always starts as per standard of Python with a def keyword, and then you can name your function whatever you want. So in this case, speak. This function returns a text or a string. So it doesn't do anything fancy or complicated. It just returns a string called woof. So the dog can basically speak woof. So down here, for example, when we create the dog, then we get the dog to say its name over here. So we print the name. And then we print wherever is returned by the speak method and it returns woof. Now, let's say we wanted to create another dog, but the dog needs to have name and it needs to have the speak method. So rather than create a completely separate class and create all these initialization method and so on, what we'll do is we will use something called inheritance and then override the behavior. So override the speak method behavior. So here we're creating a class called dog. Notice the syntax is very similar. So word class and then whatever the class name is. But this time we're going to have open parentheses, close parentheses. And in the parentheses, we're going to put in the name of the first class. And what that essentially does is it takes everything that's been created here and copies it behind the scenes. So it's able to have attribute of name and the speak method. But then here, the interesting thing you can do, you can override what the speak method actually does. So you repeat the name of the speak method. So you do the same thing. So this all is exactly the same, but then the return or the body of the method is different. For the guard dog actually is not a pet. It gets angry when it sees a stranger. It's there to guard. So when it speaks with anger like this. So when you create now a class object out of the guard dog and give it a name of Bruno, notice in the guard dog, we didn't have the initialization method, but yet you are able to do this. Then when you print the guard dog name, you can see it's Bruno, but what it speaks out is different to a pet dog. So the normal dog just does both, a guard dog does this. And that essentially is known as overriding the behavior. So you basically said, actually, my guard dog needs to do something different So you just basically repeat the function name and get it to say something else. And it's as simple as that. You can override other functions if you had any, or create new ones in your classes that inherit from the original dog class. Calling the parent behavior using inheritance is very important to understand in Python. So here you can see I have a dog class. This dog class has an attribute called name. So dogs have names. This is a standard double underscore initialization method. So init method that basically allows you to do things like pass in the dog's name as Max, that gets fed into here, gets stored as the attribute of the dog. So basically like a property of the dog. So the dog has a name. Just as you as a person have a name, the dog has a name. So here the dog is able to speak and is able to say woof. So that's the dog's speak method, is defined using the def keyword, and then you can call the speak method whatever you want. So I've just called a speak, but you can call it talk, whatever you want. There's no restrictions. But then we create another class called loud dog. Now you can see how this class has been defined. You use the class keyword and then you name your class. But what we are doing different is we are inheriting from the dog class. So basically we want to copy the behavior and the attributes of the dog class. So dogs can have names and dogs are able to talk. These are the two things that we want to copy across. So that's why we inherit from the dog class and then use a colon here, just as you do over here. Then with the speak method, you again name it as it is in the original, but this time we want to override it and get it to do something different. But we also want to keep what it actually says in the original. So what we do is we use a create a variable here, base. This is just a standard variable, nothing strange. But what that variable actually holds, it's something called super. Super is a built-in method into Python for classes. So you call this super method, and that what it does is, because you're inheriting from the dog class, it will call the speak method on the dog class over here. So it will call this method, and this method returns a string called woof. So it's going to store that woof string into this variable. And then because we've named this function speak, when you create an object out of this class, it will use the speak method. And this speak method returns what was originally said. So woof was originally said, and then it will change it to uppercase. So this will be your capitalized string, and then it will concatenate and add in 3 exclamation marks to make it sound louder or shouting. So if I run this by clicking on the play button and then run this over here. So here you can see the first dog is a normal dog. So we create the normal dog, get it to say its name and speak. And you can see the output name and speak. So it just does a woof. But then we create a loud dog. So loud dog is basically this. It inherits from the dog class. So we can pass it a name, get it to say its name, print its name, just as we do over here. And then you can see the name output. But when it speaks, you can see this is now all uppercase woof versus the lowercase there. And it's got the additional 3 exclamation marks, which we added over here. So the moral of the story is you can use the super function here or the super class to call its speak method, store it in a variable, and then get the speak function to return whatever was the string passed in here into this base variable and concatenate it, change it slightly. And then when you run the speak function, you get a slightly different output versus the original. This is done by inheritance, overriding the function speak and then calling the parent behavior.